What's up, Mustangs? Miss Titus here, and today we're going to talk about table building applications. So the mathematical process is going to be the same for building a table. The only thing that we're going to add are some questions that are applications of that table. So for each problem, complete the table and answer the questions that follow. If you take a package to the post office to be mailed, the clerk will determine how much you must pay by weighing the package. The table below shows several weights of packages and the postage due. See if you can figure out the rule for determining postage due and complete the table. Alright, so the first thing that we're going to do is find our delta y and our delta x. If I look over here in my x column, I can see that my x values are increasing by 1. If I look over here in my y column, I can see that it's increasing from 30 to 55 is going to be 25 cents. From 55 to 80 is going to be 25 cents. And from 80 to 105 is 25 cents. So over here I'm going to simplify my delta y over my delta x. It's going to be 0.25 over 1, which is just going to simplify to 25 cents. So now that I know my coefficient, I can go and write it down the front of the process column. Alright, now that I figured out my coefficient, I'm going to go ahead and fill in my x values. 1, 2, 3, 4, and then I want to find 6, 10, and 15. Alright, so I'm going to multiply my two values to see what happens or what I need in order to get to the y value. So 0.25 times 1 is 0.251 times 1 is 0.25, and the difference between 30 cents and 25 cents is 5 cents. So that's going to be my constant. So I'm going to go ahead and say plus 0.05. And then let's see if that works for our second set of values. 0.25 times 2 plus 0.05 is 0.55. So I know that I found my constant value. So I'm going to go ahead and write that all the way down. Alright, now that I have my coefficient and my constant, I can tell you that my rule is 0.25x plus 0.05. And then I can go to my table in my calculator and tell you the rest of these values. So I'm going to go to y equals. I'm going to enter in my rule 0.25x plus 0.05, and I'm going to hit second graph and go to my table. Okay, so the value for 1, 2, 3, and 4 check out. So let's look at the value for 6. When x is 6, when the pound weighs 6 ounces, it costs $1.55 to ship. Okay. When the package weighs 10 ounces, it's $2.55 to ship. And then if I scroll down to 15, I can see that it's $3.80 to ship. Okay, so now that I'm done with my table, I'm going to answer some questions. The first question A says, which statement makes more sense for this problem? The weight of the package depends on the postage, or the postage due depends on the weight of the package? That's right! The postage due depends on the weight of the package. In this situation, the postage due is our y value, and we know that y depends on x, the weight of the package. So which of these values matches with the independent variable? Well, the independent variable is x. So if I look up here, I can see x is the weight of the package in ounces. The dependent variable is y, and if I look up here at the top of my y column, I have postage due in money. So that's going to be my dependent variable. So what is the delta y over delta x for this table? They're asking us what's the coefficient. And here the coefficient is 0.25. And that stands for 25 cents, right? 25 cents per 1 ounce. What is the equation for this table? Remember, equation always has y equals. It's just going to be our rule with an y equals added. F, how much would it cost to mail a package weighing 2 pounds? Okay, well, if I look over here, I see that the X stands for the weight of the package in ounces, and that will tell me how much I will have to pay. But this is not in ounces, this is in pounds. So first of all, you have to remember that 1 pound is equal to 16 ounces. So let's convert this. If it's going to be 2 pounds, I'm going to do 2 times 16, and I end up with 32 ounces. So really I want to know how much it will cost to ship a package that is 32 ounces. So I'm taking out x from my equation and I'm plugging in 32. So let's do that real quick. .25 times 32 plus 0.05, and I end up with $8.05. Alright, how much would it cost to mail a package weighing 0 ounces? Well, technically, guys, if you're mailing a package that weighs 0 ounces, you're not mailing anything, so you wouldn't pay anything. But what they're really asking us to do is to plug in 0 for x to our equation. And so let's do that right now. 0.25 times 0 plus 0.05 is going to be 0.05. So we're going to pay 5 cents. Would it be reasonable to have a package that weighs -5 ounces? Why or why not? Well, hopefully you would say that this is not reasonable. And the reason would be because weight on Earth can't be negative. Okay? We never have negative ounces or pounds. Would it be reasonable to have a package that weighs 1 million ounces? Why or why not? Well, let's see how many pounds that would be, and then we'll see if it's reasonable. So I'm going to do 1 million divided by 16 ounces per pound. That's 62,500 pounds. I'm going to say, is it reasonable to ship something or send a package, let's just say like you sending a package at the post office? No, that is not reasonable. And I Googled it, and cars only weigh about 4,000 pounds. And if you're going to the post office, you're probably not shipping a car, so you're definitely not shipping anything 62,500 pounds. Okay. With the graph of values in this table representing increase or decreasing function, well, let's go back and look at them. Our y value, our price, is always increasing as x, the weight, increases. Because we have an increasing relationship, then this is going to be an increasing function. Basically what we're saying is that if you graph this on a coordinate plane, as x increases, y increases. The graph would be going up and to the right. So what would be some reasonable x values for this situation? Now I'm going to cross off x values and write the word that we learned last chapter when we talked about functions, and that is domain. So what is a reasonable domain for this function? So remember that x stands for the weight in ounces. Okay, so this is pretty subjective, but let's think about it logically here for a second. We'd already said that weight can't be negative, so that's going to be our lowest value. But if we're talking about domain, x always goes in the middle. So we want to say that all of our weights are going to be between 0 and what? Well, reasonably speaking, if you're sending yourself a package at the post office, it's probably not going to weigh more than 100 pounds. If it's 100 pounds, that is 1,600 ounces. So what we're going to say is that our domain should be anywhere between 0 and 1,600 ounces. Now, what would reasonable y values be for this situation? Well, our money, the money that we spend, the cost, is never going to be negative. It's never going to be negative. So we're going to say that our y values are going to be anywhere between 0 and then let's calculate what this would be. So say we used our rule, 0.25x plus 0.05, and plugged in 1,600 for a 100-pound package. we would be spending $400.05. So we're going to say that about our range is going to be anywhere between $0 and $400. Okay? So when we ask for reasonable X and Y values, we're talking about a reasonable domain and range. Well, a reasonable domain for a weight of a package you're shipping is 0 to 1,600 ounces. And then a reasonable range for price would be $0 to $400. If you're spending more than $400 to ship a package, you might want to reevaluate how you're sending it. Alright guys, that's all I got for you today. I hope that was helpful. If you're gone, you are to complete tables 2 and 3, so the next 2 pages in the packet, and then when you come back on Wednesday, we will complete the rest of the pages. Let us know if you have any questions, and as always, stay strong.